In this video, we are going to solve the Leetcode problem of the day, and the problem is apply operations to maximize score. Now, since the problem description is too big, I am going to take you to the drawing pad and explain you the problem first. So what are we going to do is, we are going to first understand what is this particular problem all about, and then we are going to understand what is the approach to solve this particular problem. And trust me guys, the first thing which you need to understand is what is this question all about. Question is too complex to understand, and if you understand the problem, so although the question is hard level, it will become medium level for you. In this particular question, we are given two inputs. There is an array and there is a number k. We need to give an output, and this output should be the maximum value possible, or we can say the maximum score possible. So how are we going to create the score? We have some rules, we have some process. Initially our score is going to be 1, and then what we need to do is we need to perform an operation. This is our operation, and we need to perform this particular operation k times. So since the value of k is 3, we need to perform this particular operation 3 times, and after performing this operation 3 times, we will have to try to maximize our output. So the maximum output possible for this particular example is 4788. This is the example number 2. I'm trying to explain you the question using example number 2. The first thing what we need to do is we need to choose a sub array from the array. Now we have an array, right? We have to choose a sub array. For example, this is a sub array, or this is a sub array, and even we can call a single element as a sub array. So first thing, choose a sub array, and the rule is you cannot choose the same sub array 2 times. Now whatever sub array you are choosing, you will have to find the number which has the highest prime score. For example, you chose a subarray this 12, 14, and 6. Every number is having a prime score. The prime score is something different. Now don't confuse yourself with the initial score which we have. This score is something we are going to give in the output, and the prime score is something which every number will have. Okay, so 12, 14, and 6. If you choose this particular subarray, every number will have a prime score. What we need to do is we need to find that number which has the highest prime score out of all of it. And the prime score of a number is the number of unique prime factors that particular number has. For example, the prime factors of 12 are 2 into 2 into, this will make 12, right? For 2 into 2 into 3 is going to make 12. Now how many unique do you have? You just have 2 and 3, which are unique data. So the prime score of 12 is going to be 2. Okay. Similarly, the prime score of 14 and 6, all of them will have the same prime score, that is 2. I will tell you in detail that how we calculate the prime score. Now, you will have to choose a number out of 12, 14, and 6. And since the question is saying that find the number which has the highest prime score, and we chose a subarray in which all of them have the same prime score, we will have to choose the number which has the least index, that is, it is in the left side. So in case we choose a subarray 12, 14, and 6, the number out of this subarray is going to be 12. And what we need to do out with this particular number is we need to multiply our current score by the number which we have got. So our current score was 1. We multiply 1 by 12, and now our score is 12, right? Now I don't know if I'm making the correct decision or not by choosing this particular subarray. Now what is the factor which is driving your decision making here? The factor is I will have to try to maximize the output. Now do you think that this particular subarray which is contributing 12 out of it is going to maximize the output? We don't know yet. Okay, but the output we know is 4788. So here the question is, how do we find which subarray to choose? We will find the answer for this question after we compute the prime score of each number. So let us do it. So this is our input. So for 19, the prime factors are only 19. So the prime score of 19 is going to be 1. Just one unique data we found, right? What about 12? In case of 12, you will notice that we can multiply 2 into 2 into 3, and this will be equal to 12. And how many unique data did we got? 1 and 2. We have two data, right? 2 comma 3. So prime score of 12 is going to be 2. The prime factors of 14 are 2 into 7. This is going to make up 14, and total unique data is 2. One is this one is this one. So the prime score of 14 is going to be 2 again. Now if you try for all other numbers, you will notice that it is 2 for all other numbers. 6 will be equal to 2 into 3, 10 will be equal to 2 into 5, and 18 will be equal to 2 into 3 into 3, right? All of them have total number of unique prime factors as 2, 2, and 2, right? Now we need to choose a subarray. But before we choose a subarray, we know that we have to maximize our output, right? Maximizing our output means we have an initial score of 1. We need to multiply it by some number and maximize it, right? So what is the number you can multiply 1 with and make it highest out of this particular data? So it is 19, right? So can you create a subarray in which 19 can be chosen as the number? That is, 19 will have the highest prime score. Yes, at least we can make one subarray like that, which is 19 itself, right? And we know that the value of k is equal to 3. So in the first operation, we multiplied 1, which was our initial score, by 19. And the reason is we have one subarray in which 19 is the only element, so the prime score 1 is going to be the highest. And which number has the highest prime score? It is 19. So we multiply 1 by 19 and our current score is going to be 19. Now we need to perform two operations. Choose another subarray. Now our focus will be to choose the maximum number again, right? This is because if you multiply 19 by another number which is maximum, then again you will have the maximum output. So which is the maximum number out of this? It is 19. So can you create another subarray which is not this one, because we cannot choose a subarray two times. So can you create another subarray for which the prime score of 19 is the highest? We cannot create it. If you try to do it, this is one subarray which we have already chosen. If you try to increase the size, you will notice that with any subarray, if you will try, you will notice you cannot choose 19. The reason is the prime score of 19 is less than all of the other numbers, right? It should be highest, but it is not highest. So if we have a subarray 19 and 12, so we know that we will have to choose the number 12 out of it. The reason is 12 has the highest prime score. So multiply 19 by 12. But do we need to choose this one? No, we should not be doing it. So let us try with the next biggest element, which is 18. So can I create another subarray for which 18 has the highest prime score? So yes, we can do it. We can create this particular subarray, and this particular subarray has just one element which is 18. So the prime score of 2 is highest in this. So we performed another operation, and for this the highest number is going to be 18. We multiply 19 by 18 and this will be equal to 342. So now we are just left with one more operation. So we can perform one more operation, and now let us again try to make another subarray for which 18 has the highest prime score. So if this is our subarray 6, 10, 18, we will have to choose 6 because all of them have the same prime scores. So all of them have the highest prime score, and we will have to choose the leftmost, which is 6. So I cannot choose 18 anymore, right? What is the next biggest element? It is 14. So now can I create a subarray which has 14 as the highest prime score element? Yes, we can. And actually, we can create multiple such subarrays. We can create this subarray, or this particular subarray, or this particular subarray, or this particular subarray. So that's total of 1, 2, 3, and 4 subarrays. We can have 4 subarrays for which the prime score of 14 is highest, right? Although we know that the prime score of all the elements are 2, so all of them are same. But we know that 14 is at the leftmost side. 14 is at the starting index of this subarray, so we can choose 14 out of this. Now, since we are just left with one more operation, so we can choose any of this subarray and multiply our current number 342 with 14, and the output is going to be 4788. That's the output we need. So here you will notice that with 19, you can create one subarray for which you can choose 19. For 18, it is 1. For 14, it is 4, right? So our first task is to find how many subarrays I can create with each element for which this element is going to be my chosen number. That is, this particular element is going to have the highest prime score. Now, this is a very tricky part. We'll have to understand it in detail. These are your numbers. These are the prime scores of your numbers, and we have a table. These are my numbers, and these are the indexes of that number. What we need to do is for each number, for example, for 14, let us take an example for 14, we will have to find out how many left subarrays can we create for that number 14, such that 14 is the number we choose out of that subarray, and how many right subarrays can we create for our number 14, in which 14 will be our chosen number. And why are we doing this? We are doing this because we need to find out how many subarrays can we create for each number such that that number is chosen out of that subarray. So we saw that for 14 we could create like 4 subarrays in which 14 will be our chosen number, right? For 18 it is just one subarray, for 19 it is just one subarray. So we will see the process of finding out this. Now what we need to do is for each number we need to find the index or the boundary in the left hand side. For example, for 14, we need to find a boundary in the left hand side till which I can extend my subarray and have 14 as my chosen number. So with 19, I cannot extend any further than this particular boundary, which is my starting index. So since I'm not able to extend from this point, it means that I can create one subarray like this. And if I try to expand my subarray in the left hand side with 19, I will not be able to do it, right? This is my boundary. Okay. So in case the boundary is the starting point, the index which we are going to store is -1. For 19, it is going to be -1. Now, in case of 12, how much can I expand in the left hand side such that 12 is my chosen number? So I can again go till this boundary, because if I try to create a subarray from 12 to this particular boundary, which is 19 and 12, I will be choosing 12 only because that is have the highest prime score. For 12 also, my leftmost boundary is going to be -1. Now, what about 14? How much can you expand 14 in the left hand side? You try to expand 14 from this place to this place, this is your subarray. If you just try up to this point, you will find that you will not be able to do it. And the reason is your subarray is having two elements and the highest prime score is 2. the leftmost number is 12, you will not be choosing 14. So what is the boundary for 14? The boundary for 14 is index number 1, right? I cannot go any further than this if I try to move left hand side from 14. That's the important thing to notice here. So the value for 14 is going to be 1. What about 6? Can you expand 6? Try to do it. We start from 6 and we try to go left. And once we moved to this point, this is our subarray, we found that we cannot choose 6. This is because 14 and 6 is our subarray and the prime scores are 2, 2 and 2. What is the highest? Highest is 2 and both have the highest as 2. So the leftmost value is 14, right? In this case, if this is the subarray, we cannot choose 6. So for 6, this is going to be our boundary and the index is going to be 2. We cannot go any further than index number 2 for 6. Now what about 10? Again, for 10, if you try to expand in the left hand side, you will notice that the value which you will have to choose is 6 and not 10, because the prime scores are same, right? And the leftmost value is 6. So again, we cannot proceed any further when we are trying with 10 in the left hand side. So what is the boundary for 10? It is going to be the index number 3, right? This is the boundary. 10 cannot go any further than this particular boundary. And for 18, it is going to be 4. Now what are these indexes telling us? How many subarrays I can create for which I will have to expand in the left hand side. So these are the indexes, right? Now, what is the actual number of left subarray we can create with 19? See, the index of 19 is 0. It can go till this point, -1. So their difference is going to be the number of left subarray I can create with 19, for which 19 is going to be my chosen value. So the difference of 0 and -1 is 1, right? 0 minus -1 is going to be 1. The difference of 1 and -1 is equal to 2, right? The difference of 2 and 1 is going to be equal to 1, right? And the difference of 3 and 2 is going to be 1. The difference of 4 and 3 is going to be 1. The difference of 5 and 4 is going to be 1. Now this value left is indicating how many left subarrays can I create with my number such that my number is going to be chosen out of it. So in case of 12, you see the value is 2. It means I can create 1 and 2 subarrays which are going in the left hand side and I will be choosing 12, right? So that is how we can find the number of left subarrays, right? For each of the element. So first we need to find out the indexes and then we need to find out how many elements can we create by using the difference of the current element index and the index we found. We are going to do the same thing for this case as well, for the right subarrays. For 19, how much right can you expand till the point that 19 is a chosen element? Well, we cannot proceed any further apart from this boundary. The reason is if we try to proceed 1 point, we will find that this will be our chosen element. The reason is same. The prime score is more for 12, right? So 12 will be chosen. For this one, we cannot proceed any further apart from the boundary index 1. What about 12? So from 12, I can proceed to the last point and 12 will be our chosen number, and the reason is the prime score is same for all of the element and 12 is in the leftmost side. So I can go till this boundary. So from 12, the index number 6, which doesn't even exist, is the actual boundary for 12. Okay, so for 12 it is going to be 6. Again for 14 it is going to be 6. For 6, 10 and 18, for all of them it is going to be 6. Why? Let us take a random example. So for example, let us take the example of 6 to verify this. If you try to start from 6, you will notice that you can choose this particular subarray, then go till 10 and go till 18 as well. For all of the subarrays, 6 is going to be chosen because the prime score are same and 6 is in the leftmost side. So again, for all of them, the boundary is going to be 6. Now, what is the difference between the boundary and the indexes? For 6 and 5, it is 1, right? For 6 and 4, it is 2. Again, for 6 and 3, it is going to be 3. For 6 and 2, it is going to be 4. And now for 2 and 1, it is going to be 1. And for 1 and 0, it is going to be 1, right? Now, we know that the number of left subarray I can create and the number of right subarray we can create. We just need to multiply these numbers and we can find how many subarrays I can create with each of my number such that that number is going to be chosen. So 1 into 1 is going to be 1, 2 into 1 is going to be 2, this is going to be 4 into 1, this is going to be 3 into 1, going to be 2 into 1, and this is going to be 1 into 1. From here we found that for 19, for 18, we can just have one subarrays. For 14, we have 4, and you remember for 14 we had 4, right? So this is the ultimate logic to find out how many subarrays we can create for each number. So we have a k, right? K is equal to 3. Let's say not 3 but 5. So if the value of k is 5, how are we going to choose what number we will have? So how are we going to multiply our initial value 1, right? So let us see that. See, we can perform the operation 5 times. And first we need to choose the maximum number. The maximum number is 19 and we can choose it for maximum of 1 time. So we can multiply 1 with 19 and now we cannot choose 19, right? So 1 will be reduced to 0. Number of operations left are 4. Again, since we have 4 operations, we are going to choose the next number which is the highest and it can be chosen. Now 19 cannot be chosen because it is 0 now. It can be chosen for 0 times. But for 18, it is 1. So next number we can choose is 18, right? And again, the 1 is going to be reduced and it will become 0. This value 4 is going to be reduced and we have 3 operations and we have multiplied 1 with 19 and 18. 1 was our initial score. Again, now we can apply three more operations, and the next highest number is 14, right? 14 can be chosen for 4 times, and since we have just three operations left, I can choose 14 for all those three operations, right? So in this case, the number of operations are going to be reduced from 3 to 0, and we are going to multiply 19 with 14, 14, and 14 three times. And after this particular value 4 is going to be reduced to 1. We can still choose 14 one more time, and this is going to be our final output. Yeah, we need to mod it with 10 is to power 9 plus 7, and we will be doing it. So that's the complete explanation of how are we going to solve this particular problem. Let me go into the coding section and let me explain you how we are going to code this problem in Python. So first of all, we need to create a value mod, which is going to be equal to 10 is to power 9 plus 7. That's because we are going to mod our answer with this particular value. Then what is the length of our number? So L is equal to length of the numbers we have. And then we have to calculate the prime score of each number, and we will store the prime score of each number in data array or data list. Let us have a loop for n in nums. We are going to calculate the prime score of each number n, right? So this method prime score is going to give us the prime score of every number n, and it will be stored in the data. So let us create a function for this, def prime score, and then it will accept a number. And initially we will start with I equal to 2. This I equal to 2 means we are going to start with the prime number 2, and we are going to store all the unique prime numbers. Answer is equal to set. We will have a set, and we will perform some operation while I into I is going to be less than equal to n. Now this is the prime number rule. We are going to follow this. Now for every value of I, we need to check if the number n can be divided by the value I. So n mod I equal to 0. And then we are going to add this in our answer. Answer dot add I. And since answer is a set, it will have all the unique values only. And then we are going to divide our number n with I, right? And every time we come out of the loop, we are going to increase the value of I, right? We are going to check with the next number. And when we come out of our main loop, we are just going to check one more condition, that if the value of n is more than 1, we are expecting it to be equal to 1, but if it is more than 1, then we are also going to add answer dot add n. N is the current number which we have, right? And in the last, we are going to return the length of our answer. So this is going to be the prime score of our given number n. This is the function which is going to give us the prime score. So now we have the prime score of all the numbers in the data array. Next is what we need to do. We need to create the left subarray, right? So left is going to be -1 for all the elements as of now. Okay. And then we are going to create a stack. Now the monotonic stack is a special stack in which we fetch the number either in increasing order or in decreasing order, right? So there is an order attached to it. Now we are going to fetch our number for I in range of L. L is the length of our numbers. We are first going to see if we have an element in stack or not, while stack, and there is one more condition, and the data for the last element which is there in my stack, this has to be less than the data which is for the current element. Now in case this condition is true, we are going to pop out an element from our stack, s.pop. And next is, when we come out of the loop, left of I, this will be equal to stack of -1 only if there is an element in stack, else it will be -1. And then we are going to append the current index in the stack, and this is how we are storing our leftmost index. Again, we need to do the same logic for rightmost index. So create a right array. So let me take some space here, right array, and this will be equal to L into L. Now for left, we initialize everyone with the -1 because the leftmost boundary is -1. For right, the rightmost boundary is L. So let me initialize our stack again. This time we are going to run a loop in the opposite direction from 18 to 19. So from index number 5 to index number 0. For that, for I in range L -1, -1, and -1. This is how we run a opposite loop. Now again, while we have an element in the stack and the data in my stack of -1, that is the prime score of the last index which I have in my stack, should be less than equal to the data of I, that is the prime score of my current element. And if it even if it is equal to, we are going to choose our element. And the reason is, if we are moving the right hand side, we are going to choose the leftmost element, right? So we can expand our boundary. But when we were going in the left hand side, we had to choose the leftmost element. And in case of equal, we cannot expand our boundary, right? So in this case, if this is true, we are going to pop an element from our stack. And then the rightmost boundary for current index is going to be st of -1. That is my last element which is there in the stack. Only if we have an element in a stack, else it will be remaining to L, which is the length of our array. And finally, we are going to append the data, st.append I. Now, after this operation is performed, we will have the left and right boundaries for each element. Now, we are going to create the number of sub-arrays which we can create. So, numbers I, so it will be nums of I, that is our actual number. Now, let's choose for the leftmost boundary. So, the current index I minus the boundary in the left I minus the boundary for that element. This will be the total number of left sub-array. This will be multiplied by total number of right sub-array. So, it will be right of I and minus I. So this is the difference we are going to calculate. So this will be left subarrays, will be right subarrays. Multiply it and you will find total number of subarrays you can create for each numbers. And also we need to run a loop for I in range of L, right? Now once we have the combinations ready, the we need to sort it as well because we are going to process the highest element first. So combo dot sort. In sort we need to reverse equal to true, right? Because highest to lowest, and the key is going to be the first element because we have two elements in the data. So our actual data is going to be the first, is going to be the key to sort. So lambda of x, and we have to choose x of 0. And finally we can now work on creating our result. Now what is our initial result? It is 1. Run a loop for num comma count in combos. We need to check if the value of k is less than equal to 0, and if it is, we need to break out of the loop. But if it is not, we need to use a number, right? We need to use a number which is minimum of k and count. How many operations are we left with, and how many operations we can perform? We need to choose the minimum out of it. And then the result is going to be result multiplied by, we need to power, we need to use the function power, and in power we can pass the number and the number of times we can use this particular number. And also we need to use the mod as well. So for larger number, this is a better process to mod the values in the power function itself, and then we are actually going to use the mod. So the whole result is also going to be mod of this particular 10 to power 9 plus 7. And then the value of k is going to decrease. So k minus equal to use. How many we have used? This is going to be decreased from k. And finally, we are going to return the value of result. And now, before you submit the code, I have few typos in the code, which is the function name is prime score. So I will have to use this function name prime score here in the data. And here you will find that s should be st, and this combos should be combo. So there were just few typos. So I think now this code should run. Submit the code and you will find that all the test cases are accepted for this particular problem. Yes, you can see all the test cases are passed, and this is a good solution. And this particular problem was too complex to understand, and so this seems to be a pretty efficient solution for this particular problem. I have tried my best to explain you the problem in the best way possible, as well as the approach, but honestly this problem is complex. So I don't expect that you get all the 100% out of it. But if you will try to, read the problem again, try to understand the approach which I have explained you in the particular video again, then you will for sure understand everything, the 100% out of it. So I hope you like this video, like the explanation as well. And if you did, then make sure that you hit that like button. And if you are not subscribed to the channel, then subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching, guys.